All right, for question 1, we have 10 to the power of 4. By our definition for exponents, that means multiply 10 by itself 4 times. So I'll write this one out. And this is going to be 1 followed by 4 zeros. So it simplifies to 10,000. You can check this in your calculator too. That might be worthwhile. And okay, we get the same thing. Perfect. If we compare this to negative 10 to the 4th, this would be negative 10 times itself 4 times. And the answer is going to be positive since there's a total of 4, an even number of negatives. So it's the same as the previous answer. Now if we have negative 10 to the 5th, I think this time I'll just say that this whole thing is negative because there's going to be a total of 5, an odd number of negatives. And we're going to have a 1 followed by 1, 2, 3, 4, 5 zeros. So I'll just double check this one. Negative 10 to the power of 5, and I do get that. Okay. Now we have 0.5 squared minus 0.5 cubed. So, okay, for this one, 0.5 squared is going to be 0.25. 0.5 cubed, 5 cubed is 125. The decimal point will move 3 places. That's 125. And if we simplify this, we get 0.125. No surprise there. No problem in checking our work along the way. All right, so for 5, this is the absolute value of negative 8,128, pretty random number there. And all this means is since it's a negative number, it makes it positive, so it'll be positive 8,128. Okay, moving on. The square root of 0.0625, and then to that we're going to add 1/3 minus 1/2 in absolute value. So we got these two separate pieces here. I think I'll first start with this square root. I think I could actually solve this without using a calculator, but I'm just going to go right there first. So if I type this in, it gives me an exact value. It's 2 decimal places, but we get 0.25. Great. Okay, but now for the absolute value of 1/3 minus 1/2, I need to figure out what this number is before I apply the absolute value, because this is, is it positive, is it negative? I'm not really sure. For a common denominator, we'll use 6. That means I multiplied the first fraction by 2. So 1 times 2 is 2. I'm multiplying this fraction by 3. So 1 times 3 is 3. And if I now just subtract the numerators, 2 minus 3 is negative 1. This is negative 1 over 6. So I'll put this middle step in here that we're really taking the absolute value of negative 1/6. And therefore, we have 0.25, and that'll be plus 1/6. Now, our goal is to write this as just one number, and if you try using a fraction for a 1/6, this decimal goes on forever. I see that in my calculator. So to actually combine these two together, I'm going to convert 0.25 into a fraction. So 0.25, like literally by definition, that is 25 over 100, right? This is tens hundredths place, so that really means 25 over 100 plus 1 over 6. And this fraction can be reduced to 1/4. It's just one way to go about it, but I want to add a 4th and a 6th. So for a common denominator, I'm going to use 12 because I can multiply 4 by 3 and 6 by 2 to get 3/12 is 1/4 and 2/12 is 1/6. I now simply just add the numerators and I get 5/12. That is an exact answer and it's a fraction that can't be reduced. For question 7, we have the square root of 2 cubed minus 3 squared. And this is a situation where before you actually apply the square root, I have to simplify what is underneath it first. So we know what cubed means. 2 cubed is 8. and 3 squared is 9. So I still have to simplify. 8 minus 9 is -1. This is a problem. If I type the square root of -1 into my calculator, I get an error message. Mine actually now says non-real answer, so this is no good. There's no solution. There's no value that this is equal to. For question 8, we have 5 to the power of 2 to the 4th minus 4 squared. So this is kind of confusing looking, but 5 to the 2 to the 4th minus 4 squared. So for this one, before we figure out what we're doing to 5, I'd have to simplify this entire exponent. So I have to simplify this thing. 2 to the 4th minus 4 squared. Let's do that off to the side. 2 to the 4th is 2 times 2 times 2 times 2. That's 16. 4 squared, okay, that's 16 as well. This means that 2 to the 4th minus 4 squared is 16 minus 16, and that's just 0. So this is really 5 to the power of 0. And we said in class that anything to the power of 0 is equal to 1. The only issue would be is if we had 0 to the 0, which is undefined. That didn't happen here, and that's the answer. Okay, for question 9, the absolute value of 0.1 times 25 minus 0.01 times 100. Another situation where we have to figure out what is inside the absolute value before applying it. I'm just going to work through this one directly, where if I multiply 25 by 0.1, that's 2.5. And if I multiply 100 by 0.01, that is 1. The absolute value of 2.5 minus 1, I can still work on the inner portion of the absolute value. That's 1.5. And the absolute value of a positive number is precisely that value. For question 10, we have the square root of -50 squared. Kind of looks like this could be an issue because I see a negative under the square root. But before I apply the square root, I'd have to simplify -50 squared. So I do know that this negative is going to go away when I square it, and I have to just know what 50 squared is. So it's going to be a fairly large value. This is the square root of 2,500. And when I take the square root of that number, no surprise that we get 50. So this is kind of interesting, where if you first square this, it makes it positive, but then it just goes back to the positive value at the very end. And so for 10, the answer is 50. So for all of those questions, we have been using order of operation to some degree. But we're going to use these in more detail in questions 11 through 16. So let's start there. For 11, we have 9 times -8 plus -4 squared. Following order of operation very carefully, I'm not going to multiply or add, but first I'm going to apply the exponent. -4 squared is a positive 16. Now that exponents are gone, I'm going to deal with multiplication, which is 9 times -8. That's a negative number because one of them is negative, and in fact it's -72. I'm now adding these two numbers together. That is -72 plus 16. It's got to be a negative value. This is -56, which I just checked on my calculator, and that's the final answer. For question 12, we have -1/2 times -2/3 plus the absolute value of 4/3 minus 11/3. All right, so in terms of order of operation, technically I mentioned there's this implied parentheses within the absolute value. So just being careful, I'm going to simplify this first and take the absolute value of that number. And we can do this work off to the side. Nothing wrong with that. So what is 4/3 minus 11/3? Well, the denominator is the same, so I don't need a common denominator, but I am subtracting 11 from 4. So we get -7. This means I get -1/2 times negative 2/3 plus, that's the absolute value of negative 7/3, which becomes positive 7/3. So what is next is multiplication and then addition. When I multiply these two numbers together, they're both negative, meaning the answer is going to be positive. And I'm going to do a little shortcut first where I can cancel any common factors between the numerator and the denominator. This means that the answer is a positive, but it's positive 1/3 because 1 times 1 is 1, 1 times 3 is 3, and it's positive. I'm adding that to 7/3. It's the only operation left, and I get 8/3. It's fine to leave your answer as an improper fraction. You could convert it to a mixed number if you want to. 3 goes into 8 twice with 2 out of 3 left over. 2 and 2/3, 8/3 are one and the same thing. Both answers are completely acceptable. For number 13, all right, we got 5 times negative 0.5 minus 7 times 0.5 all over negative 4 squared minus the square root of 4. Again, these implied parentheses where you have to figure out the numerator and the denominator separately before you divide. That's what this gigantic division symbol means. I'll start with the numerator. We have 5 times negative 0.5, that is negative 2.5. And then we have subtracting 7 times 0.5. So that's subtracting 3.5. In my denominator, I have my exponent of negative 4 squared, which is 16, minus, and there's nothing wrong with applying the square root here. The square root of 4 is 2. Okay, moving along. If we look at the numerator, we're taking the difference. That's going to be negative 7, because we can just directly subtract those two things. And then 16 minus 2 is a positive 14. So this is one number. I mean, there's no real division to do. Perhaps maybe just knowing that my whole answer is negative. 7 goes into itself once, it goes into 14 twice, and that's my answer of negative 1/2. All right, so for 14, 15 minus 12 divided by 6 times 5 plus negative 1 to the 15th power. Okay, a lot happening in this problem. But there's this little kind of trick here where we have division and multiplication, and technically when these two appear, you would solve those moving left to right, so we're just going to be careful there. But I'm first going to start with this exponent. Negative 1 to the 15th power is just going to be negative 1. So let's fill that in. This is 15 minus 12 divided by 6 times 5, and that's just minus 1. You could put plus negative 1 if you want to, but we're saying the same thing. Next, I'm going to look at the division and multiplication, but we're dividing first. And 12 divided by 6 is 2. This is 15 minus, I just did that division, and I'll do the multiplication next. When I multiply, I get 15, that's minus 10 minus 1. And if I subtract here, I have 15 minus 10, which is 5. And then 5 minus 1, which is 4. For number 15, we have the square root of 12 cubed plus the absolute value of 21 minus 27 squared. So we're working directly under the square root first. And I guess technically, we're looking at this absolute value first as well as the very first thing we do. All right, so 21 minus 27 in absolute value. 12 cubed plus, that's the absolute value of negative 6. And the absolute value of negative 6 is positive 6. And now we can apply our exponents. 12 cubed, so I'll just do that in my calculator. That is 1,728. and then we get 6 squared, which is 36. When I add those together, I get the square root of 1,764. Okay, so unless you happen to know this one, I wonder if it works out nicely. I'm just going to check that in my calculator, and we get 42. All right, so for 16, this is 12 plus 15 divided by -5 times 2 plus 1, all divided by -0.01 to the 4th power. All right. I'll work in the numerator first, and here again we have that multiplication and division, but we're doing the division first. So this is going to be 12 plus. Now, we're dividing a positive by a negative, so I know the answer is going to be negative, and 15 divided by 5 is 3, so that's -3. So what I did here was I noted to do this division first. 15 divided by 5 is 3. One of the values was negative, so that tags along. You could have written this as -3 times 2, but I'll leave it just like this for now. Both of those are completely acceptable. And in the denominator, I can do that too. I'm going to apply the exponent before I apply the negative, but we have 0.01 to the 4th power. All right, that is 0.000000001. That's a total of 8 decimal places the decimal moved. Here you have 2 decimal places. If we double that, we get 8. So 1, 2, 3, 4, 5, 6, 7, 8. And that negative is applied second because it's multiplication, so this is really -0.01 to the 4th power. All right, so next in the numerator, the denominator is completely simplified. I'm going to multiply those two together. This gives us a -6. I'm going to choose to write this as -6 as opposed to plus -6. Both are completely acceptable, but this is 12 minus 6 plus 1, all divided by -0.1, 2, 3, 4, 5, 6, 7 zeros, and a 1 at the very end. So for the numerator, 12 minus 6 is 6, plus 1 is 7, and we're dividing again by this number. Now, that means the whole answer is going to be negative, and it's going to move the decimal point in the numerator 8 places. So you could do this on your calculator if you want to. 1, 2, 3, 4, 5, 6, 7. But the answer is 7 followed by 8 zeros. So that's here, here, that is 700 million, -700 million. All right, for 17, we have 4x to the 5th times x to the 10th. I'm going to add those two exponents together to get x to the 15th power. For 18, -2xy cubed times 2xy squared. All right, here I'm just going to note that all of the exponents that appear here are to the 1st power. And like we mentioned in class, you can put some parentheses around here too, just to indicate that that 3 here is being applied to the negative as well. So multiplying this 3 to those 3 exponents and this 2 to those 3 exponents, I get -2 cubed x cubed y cubed. Then we get 2 squared x squared y squared. Okay, -2 cubed is -8. And 2 squared, maybe let's put a multiplication symbol in here just to avoid some confusion, but 2 squared is 4. And now I'm going to multiply the two numbers together, so that is -32. For my x's, I have 3 here, 2 here, so that is x to the power of 5 if I add those two exponents, and the same thing goes for the y's. There's a y cubed and a y squared, and so that's my answer, -32 x to the 5th, y to the 5th. For 19, 10xy to the 5th, all to the 5th power. Again, just noting in the exponents on both 10 and x. All right, we have 10 to the 5th, x to the 5th, y to the 5 times 5, which is 25. 10 to the 5th is a 1 followed by 1, 2, 3, 4, 5 zeros. For 20, I have 1/3 x cubed y squared, and then 27 x to the 5th y to the 6th cubed. So we haven't encountered this yet. Again, there's a 1 on the exponent of that 27, and if you're dealing with a fraction, this exponent of 2 goes to the exponents of both 1 and 3. So, I mean, really, I'll put them in here, but that's 1 to the 1st, that's 3 to the 1st. The 2 is always being multiplied to the exponent. So we have 1/9, again, that's 3 to the 1st squared is 3 squared, which is 9. Okay, then we have x to the 6th y squared. Okay, now we have 27 cubed. I'm just going to write that out on my, or get that from my calculator. That's a large value. That's 19683. Then we have x to the 15th, y to the 18th. All right, when again combining these numbers, I'm just going to divide this value by 9. And it goes in evenly. We have 2,187. We have an x to the 6th and to the 15th. If we add those two exponents, we get to the 21st. And we have y squared and y to the 18th. I add those and I get 20. So for question 21, we have 15x to the 5th y squared, all divided by negative 3x to the 4th y squared. Focusing on just the numbers first, 3 goes into 15 5 times, and the whole thing is going to be negative since one of the numbers is negative, so I get a negative 5. If you'd like, you can even put 5 over 1 just to leave it as a fraction for now. Dealing next with the x's, I can just subtract the two exponents, and 5 minus 4 is 1, so x to the 1st. And we have y squared over y squared, that's y to the 2 minus 2, which is 0. So as it turns out, I really didn't need this fraction whatsoever. I'm just going to put negative 5 and leave off the 1 just because there were no denominators over here. X to the 1st, I'll just write as x, and y to the 0, I'm going to just write this as, it's a 1, so I'm not going to write it at all since it's not necessary. This is negative 5, x. Technically, y to the 0 is just equal to 1, but you don't need to write it. Okay, x to the 10th y over x to the 4th y to the 5th. I'm again just going to go to this method of subtracting the exponents. This is x to the 10 minus 4, which is 6, and then y to the 1 minus 5, which is negative 4. And this means that if we think of y as a fraction, it'll be y to the 4th, positive 4th, in the denominator. This is x to the 6th times 1 over y to the positive 4th. And I can write this in one fraction if I treat the first thing as a fraction too. This is x to the 6th over y to the 4th. Keep in mind that it is completely okay to jump from this step to this step. I know this thing has to go into a denominator, and this is currently going to be in the numerator. For 23, we get negative 2x cubed to the negative 2. Again, want to be really careful here and note that this is negative 2 to the 1st. When I multiply that negative 2 exponent, I get negative 2 to the negative 2, and I get x to the negative 6th. I'm going to make both of these exponents positive by putting them in the denominator. The last thing to do is square negative 2, and that's positive 4. So I get 1 over 4 times x to the 6th. Okay, 3x to the negative 3, all to the negative 3. Again, being careful to say that that's 3 to the 1st. Didn't really need the parentheses there, but it doesn't matter if they are present. This is 3 to the negative 3, x to the positive 9th. Here, I'm just going to put that 3 to the negative 3 into the denominator and write this as x to the 9th over 3 cubed. 3 to the power of 3 is 27, and this is my final answer. or 25. I have x to the 5th, y to the negative 2 to the negative 6th power times x, y to the 4th, all to the negative 1st. Place a 1 here, and directly multiply these exponents. We get x to the negative 30th, y to the positive 12th, then we have x to the negative 1, y to the negative 4th. Before I start moving around things between numerators and denominators, these x's, I can simply add those exponents together. Negative 30 plus a negative 1 is x to the negative 31. And y to the 12th plus y to the negative 4th, it's 12 minus 4, that is positive 8. I can now say that the final answer is y to the 8th. That goes nowhere, but x becomes positive 31 if I move it to the denominator. Okay, so solve question 26. What I'm going to do, there's a couple of approaches you could take. You could actually simplify what's in the parentheses first and then apply the exponent of 3. But following with our approach that we've been doing so far, I'm just going to multiply that 3 to every single exponent. That's 2 cubed x to the power of 15, y to the power of 18, divided by 4 to the power of 3, x to the power of 6, y to the power of 15. Dealing with the numbers first, 2 cubed is 8, and 4 cubed is, I believe, 64. Then we have x to the 6th and y to the 15th. So 8 goes into 64, I mean, this is no surprise, I guess, goes into itself once, it goes into 64 twice. I don't need to write this 1 in the numerator, but the 2 definitely has to stay in the denominator. At the same time, I'm going to, when comparing the x's, subtract 6 from 15, as well as 15 from 18 for the y's. What this gives me is, we have x, 15 minus 6 is 9. We have y, to the 18 minus 15 is 3. The only thing left over in the denominator is the 2. The reason for this is, we had a 1 over 2. That means 2 is in the bottom. 1 I don't have to write, and I didn't. When I dealt with these, the exponents on both were positive, and that meant they stayed within the numerator. This is a fine way to write the answer. If I now look at 27, other part of the homework here, other side, we have x cubed y squared, x to the 6th, y to the 5th. And this is all to the power of negative 5. Directly multiplying exponents, I get x to the negative 15, y to the negative 10, then I get x to the negative 30th, y to the negative 25th. I'm going to subtract these exponents. Maybe I will be a little bit careful in this one. You don't have to write this middle step, I'm choosing to. I'm going to subtract those 2 exponents and then subtract those 2 exponents. This is x to the negative 15 and we're subtracting negative 30. For y, it's negative 10 minus a negative 25. I'm being careful here just because when you're subtracting a negative exponent, subtracting a negative, this becomes addition. So I'm going to put that middle step in here. This is x to the negative 15 plus 30, and then y to the negative 10 plus 25. When I add these exponents together, I get x to the positive 15th as well as y to the positive 15th. For 28, okay, we have negative 3, x to the negative 1, y to the negative 7th, all over x to the negative 6th, y to the negative 5th. And this whole thing is being raised to the power of negative 2. That's a negative 3 to the 1st power. Multiplying that exponent of negative 2 into the parentheses, we get negative 3 to the negative 2, x to the positive 2, y to the 14th, all over x to the 12th, and y to the 10th. Again, all we're doing is multiplying this exponent to these exponents here, which is how we got those values. The only exponent that is negative is now on this negative 3 squared. I'm going to move that directly to the denominator. that's negative 3 now to the positive 2. We get x to the 12th and y to the 10th. That means this is a 1 over, if we square negative 3, it's 9. So that's going to be 1/9. I'm now going to look at these two pieces, the x's and the y's. We have x to the 2 minus 12, that's negative 10, and we have y to the 14th minus 10, and that's y to the positive 4th. I guess the last thing to note here is that the only thing with the negative exponent is the portion with the x's. If I think of all these as fractions, all I need to do is take this, place it into the denominator, and then multiply all the numerators and denominators together. My answer will be y to the 4th over 9x to the 10th. So what happened again is this moved to the bottom. That left me with 1 times a 1 times a y to the 4th, or simply y to the 4th. And then my denominators, I had 9. This was now x to the positive 10th and a 1. So that gave us 9 times x, and that's supposed to be, kind of doesn't look like it, but that's supposed to be a 10. And that's the final answer. All right, now we need to combine some like terms for the next couple of problems here. So for 29, okay, 15x minus 30xy plus 27x plus 14y minus 105xy plus 5. What are all the like terms? If I start with the x's, here's a like term because it has just an x. There's nothing else. If I check out the xy's, I got this negative 30xy, and here we have a negative 105xy. That leaves me with a 14y and a plus 5. That is not like terms with anything else, so I just have to combine the blue and the red terms together. So 15 and 27, if I add those two together, just being careful here, that's a total of 42x. If I now look at negative 30 minus 105, that's negative 135xy. So again, when you identify the like terms, we are now just dealing with 15 and 27, that gave us 42. Negative 30 subtracted by 105 gave us this negative 135. We can't do a thing with this or this, so we get plus 14y plus 5, and that is it. Simplified a little, but not very much. All right, so for 30, we have 12a plus 14ab plus 16b minus a squared plus 12b squared. So you can use any letters that you like for your variables. Here we have a's and b's instead of x's and y's. If we try to identify like terms, if I start with the a, there's nothing else that has an a in it. Okay, so now we'll move along to the ab. Nope, doesn't combine with anything. So far not good. If we go to the 16b, nothing over here. I then have a squared, so that doesn't combine with anything, and b squared doesn't combine with anything else. In fact, this is it. Nothing combines, there are no like terms, so that is the answer. For 31, I have 1/3 xy squared plus 1/4 xy squared, that's already looking good, minus 2/3 xy plus 7/6 xy plus 1/2 xy squared. Okay, here we have an xy squared, another xy squared, and at the very end, another one. There's actually 3 xy squared, so we can combine all those together. And then the other two terms are both xy, so I can combine those. I think for combining the xy squareds, I'm going to look at the coefficients separately, just kind of like work on that over here before I plug it back into the problem, just because the numbers are a little bit more complicated. I want to take 1/3, add it to 1/4, and then add it to 1/2. For these three fractions, I need a common denominator. 12 will work nicely for all three of them. That means I'm multiplying the first fraction by 4, so you get 4/12. I'm multiplying the second fraction by 3, which gives us 3/12. And for the last fraction, I'm multiplying 1/2, or 2 in this case really, by 6, so I get 6/12. That's a total of how many twelfths? We have 4 and 3 is 7, and 6 is 13. 13 twelfths. What does that all mean? We have 13 twelfths x, y squared terms. I think I'll do the same thing for the x, y's. I got -2/3 plus 7/6, so I'm going to use 6 as a common denominator. That means I did not change the second fraction. I doubled the first fraction to 4. That's -4 plus 7. That is a total of positive 3/6, or just positive 1/2. That means I have 1/2 x, y, and that is my final answer here. Okay, one last one. For problem 32, got some decimals in here. All right, we got 0.1, that's just a number, 0.5, 3 variables, x, y, z. And we have plus 0.2 plus 0.6, another x, y, z. Another, just a number, 0.3. And then plus 0.7 x, y, z. I think it's very clear what the like terms are. We have numbers, and then we have x, y, z's. Again, it doesn't matter how complicated the variables are. They have to be exactly the same. So for the numbers, we are simply adding 0.1, 0.2, and 0.3. That is 0.6. For the x, y, z's, we have 0.5, 0.6, and 0.7. So let's see what we have here. That is 11 and 7. That's 1.8. And that is it for combining like terms. All right, for 33, we have x times 1 plus 5x to the 5th. And like we talked about, if we distribute, that means the x gets multiplied to both of those terms. 1 times x is x, and then x times 5x to the 5th. The 5 stays the same, but we get x to the 6th. We're noting that the exponent here is a 1, and so we're going to add the exponents to go from 5 up to 6. For 34, we have -2x, then we have 1 minus 3x plus x cubed. The distributive property says that no matter how many terms there are, you multiply to all of them. A nice thing to point out is if you have a negative out here, it's going to change the sign of everything inside the parentheses. So we get -2x, we'll then get a positive 6x squared, but then a negative 2x to the 4th. Okay, we have x squared times x plus x squared plus x cubed. When I multiply this in to my 3 terms, I get x cubed plus x to the 4th plus x to the 5th. All right, for 36, we're now going to deal with a fraction and a different variable, but we have y over 3, x plus 9y minus 27xy plus 81y squared. I think it's going to get really messy. I just won't draw these in. We're just going to note that this is going to be multiplied to all 4 terms. When I multiply this here, x's and y's can't be combined. 3 is going to stay in the denominator. My first term is going to be xy over 3. Now, when I multiply this here, if you'd like, you could even just write in a fraction if that is just a nice reference for you. All this means, and the reason I'm doing it is, this 3 will be in the denominator. This 9 here is in the numerator. So these don't multiply. This is really 9 over 3. 3 goes into 9 3 times. That means it's going to be 3 left over in the numerator. Since I have y times y, that is y squared. And for this very same reason, when I distribute this term here, it's going to be negative, so I copied that down. This 3 is in the denominator, that 27 is in the numerator. 3 goes into 27 9 times. when this y gets multiplied to the xy's, doesn't do anything to the x's, but y times y is y squared. Lastly, it's going to be positive. 3 is divided into 81. That's 27. And then we have a y times a y squared, and so we get a y cubed. I didn't really point this out in the previous problems, but note that I don't see any like terms, so I can't combine these any further, and that was the case for the previous problems too. All right, 37. We have 4xy times negative 10 minus x plus xy cubed minus 4x squared y. Multiplying this in, I'm not going to change the signs, but this will be a negative 4 times 10, that is negative 40 xy. I then get negative 4, there's two x's, so I get an x squared, and there's just a single y. I then get plus 4. I have an x and an x, so I get an x squared. I get a y and a y cubed, that's a y to the 4th. And for the last one, it's going to be negative 4 times 4 is 16, x times x squared is x cubed, and y times y is y squared. There are no like terms, so that's the final answer. For 38, we have x times, now I put a couple of parentheses in this one, so let's talk about that. If we're following an order of operation and using the distributive property, we would ignore this x and what's happening outside of these parentheses. Like, I want to fix this stuff first, combine as many like terms and multiply as best I can before dealing with this x. And since I have 3 and these parentheses, I'm going to distribute this 3 to both terms here. So let me actually draw in. I'm working within the parentheses first, and I'm going to distribute the 3 to those two terms. So now I have x, this bracket, and this 1, but 3 times x is 3x, and 3 times 4 is 12. I think it would be worth combining some like terms here. I can't combine the 3x, that's all alone, but we have a 1 and a 12, and that gives me 13. And it doesn't matter that the brackets are now different than the parentheses. The distributive property still applies, where this gets multiplied to both terms. And that means I get a 3x squared plus 13x. It does not really matter if you're writing your terms in descending order or here where they seem to be increasing. This is completely acceptable as there are no like terms and it's simplified. Okay, a couple more complicated ones here, but we have negative, then bracket, acting as just a parenthesis does, y minus x times x plus 2y plus 1, and then minus a 2y at the end. Again, working inward out, I want to deal with all of this stuff first before dealing with this negative that's sitting over here. And all that means for us is I'm going to take this negative x and distribute it into the parentheses. Now, one thing to point out is that this really means you're adding a negative x. So I'm just going to leave this as a subtraction symbol and change the sign and everything that appears in here. Here's what I mean. This whole thing is negative, bracket, we have y. When I distribute that negative x, I get this minus x squared. So I'm really treating this at the very end as subtraction. The negative tags along, but we're really now subtracting this x squared. I then get negative 2xy, and then we're going to have this negative x. Before moving forward, I want to see if there's any like terms that we can combine. The only thing I'm seeing are the y's. We have a 1y, which there's no 1 written here, and a minus 2y. 1 minus 2 is a negative 1y. I'll just write that as negative y. Then I have minus x squared, minus 2xy, minus x. There are no like terms here. This is kind of nice. When you distribute the negative into the parentheses, it just changes the sign and everything. Everything inside the parentheses is negative. That means when you distribute this negative, we now get y plus x squared plus 2xy plus x, and that's my final answer. We are at our last problem. 4 times bracket negative 5 plus 4 times x plus 1 minus 5 times x minus 3 plus 2 plus 5. So here we got this 4 being multiplied to all of this stuff. This 5 is going to be the very last thing we do because it's outside every single set of parentheses. So therefore, I'm going to work on the stuff inside the brackets first. I will just note that, okay, that means this 4 gets multiplied to only the x and the 1. This negative 5 gets multiplied to the x and the minus 3. We have 4 times negative 5 plus 4x plus 4 minus 5x plus 15 plus 2 and then a plus 5 at the very end. There are definitely like terms in there, so we're working from the inside out. For the number of x's, we have 4 here, we're subtracting 5 there. That's a total of negative 1 x's, which I'll put as negative x. And then for the numbers, we have negative 5, a positive 4, so that's net negative 1. And if we add 2 to that, I think I missed one. Let's see, that's negative 5. Maybe I'll get my calculator out here. Negative 5 plus 4, I missed the plus 15 and then the plus 2. That is a total of 16. And we still haven't dealt with that very last plus 5. But before combining this, I'd have to multiply this 4 into the parentheses, so I'll just make note of that and say we have negative 4x plus 16 times 4 is 64 and a plus 5 at the end. The only like terms that can be combined are the 64 and the 5, and this is our final answer.